In this chapter, we take up the concept of elasticity. We're going to talk about several types of elasticity: price elasticity of demand, price elasticity of supply, income elasticity, and cross elasticity. Elasticity is an extremely useful concept and a pretty useful tool. I've often said of all the things we study in microeconomics, it may be the most important, but probably the one the students understand the least. And a lot of the problem is we're dealing in percentage changes, and we'll talk about that later. But what is elasticity exactly? Well, notice my subtitle, how much does it change? Well, as we're going to see, elasticity deals with how, not just the fact that when prices go up, people buy less. The question then becomes how much less do they buy? And now we're going to actually have measures for this. Price elasticity of demand, as we indicated, we previously developed a law of demand, and so now we're going to take a look at how we actually measure this and talk about the important aspects of measuring it. Now, I will say we're not going to measure it, but we can make use of what other people have done to determine the price elasticity of demand for a particular product. We're going to let ED equal the percent change in quantity demanded divided by the percent change in price. ED, of course, is elasticity of demand. And since we're dealing with percentage changes, then ED is going to be equal to the change in quantity demanded of X divided by the original quantity demanded of X. So we have to have a change. So if we start at 10 units and we go up to 11 units and we have a change in quantity of 1 compared to the original quantity of 10. So 1 over 10 would be the upper portion or the top portion of the equation. And on the bottom you would have a change in the price of X divided by the original price of X. So the same thing. So, this is going to be our equation, and we're going to work some with it. The problem, of course, with doing this is it depends if prices are rising or falling. So to be consistent, we will use a midpoints formula. And I want to show you why we need to do that. And it's simply for consistency. Otherwise, we may be using the same numbers and getting different answers. So here I'm going to assume we have the following information. At a price of $10, we would sell 20, and at a price of $8, we would sell 30. Okay, standard demand curve or demand schedule. Using the first formula, if price goes from $8 to $10, this is a change of 25%. In other words, price has gone up by $2 from 8 to 10, and starting with our original price of $8, then 2 over 8 becomes our percent change in price. Then the change in quantity is going from 30 to 20, or a percentage change of minus 33%, because the change went from 30 to 20. That's a change of 10. It's negative since it went down, and we're comparing that to the original amount we started, which was 30. This means the elasticity, as we have measured it, is 25% divided by minus 33%, or about 1.25. Note, price elasticities are always going to be negative because of the fact that when price goes up, quantities go down, or when price goes down, quantities go up. So we're always going to see that, and eventually here we're just going to completely drop that negative sign and just assume that it is negative. But now, let's do it a little bit different way. Instead of going from 8 to 10, we go to from 10 to 8, and if we go from 10 to 8, we're going to go from 20 to 30. Changes are going to be the same, but there's going to be a little bit different situation. You're going to see the numbers are going to change. So now assume we go from $10 down to $8. This is a price change of minus 20%. Again, price has gone down by 2, but we're now comparing that to the original $10. So it's dropped by 20%. The quantity change is now 50%, or 10. We go from 20 to 30, but we're going to compare that to the original 20, so it's going to be 10 divided by 20. This would give us an elasticity of 50% divided by minus 20%, or 2.5. That means there's a big difference here and if you're using the same set of numbers I am, one of us could get minus 1.25 and the other could get minus 2.5, and therefore that doesn't really give us, that's not very useful to us. So we use a midpoints formula. For percent change in price, we use the change in the price divided by the average of the two prices. So in the case of prices, price went from 8 to 10, and I guess from 10 to 8 in this particular example. And so that's down by $2. Then what we do is we take the 8 and the 10 and we average those, giving us 9. And so 2 over 9 becomes minus 22%. Then the percent change in quantity, we take the quantity divided by the average of the two quantities, and thus it becomes 10, change in quantity, divided by the average of the two. You average 20 and 30, you get 25 or 40%. The elasticity is then 40% divided by minus 22% or 1.82. This gives us, this would be true if prices are rising or falling, so it's not going to make any difference in that case. So in this, by using the midpoint formula, the big thing is we have consistency. Price elasticity of demand. Well, we use percentages because it does not depend on the units we use. It doesn't make any difference whether they're large or small. You could use dollars, we could use cents. It would all come out the same percentage. Also, we find people actually respond to percent changes even if they do not realize it. Behavioral economics, for instance, they talk about, of an example. You go in to buy a radio and it's $40, and the clerk tells you, well, if you go across town, you can get it for $30. You can save $10. And what happens? Most people actually say, oh, I'll drive across town to save the $10. Now, on the other hand, if you're buying a car and the car dealer tells, on a $25,000 car, the car dealer tells you, well, if you go to this dealer, you can save $10. Most of us say, I don't really care to do that. So that's a waste of time. So we really kind of look at the world in percentage terms anyway. On the other hand, it seems to create problems for students in thinking in these terms because these percentages keep changing on us. If we look at the demand curve, as prices rise, a 1 unit change in price becomes a smaller percentage. So if we're starting at $5, our base is $5 and the change is 1, that's 1/5, that's 20%. When we get up to $10, a $1 change only is 10%. And the problem is, of course, as long as we're moving along that demand curve, both quantities and prices are changing, and so are the percentages. On the other hand, as quantity falls, a 1 unit change becomes a larger percentage change in quantity. What this means is that we move along a straight line demand curve, elasticity changes. And this is going to be seen in the next slide. Note, since all price elasticities are negative, we're going to drop the negative sign now and use absolute numbers, i.e. positive numbers. So here again, we see the demand curve, and I have an arrow showing going up. And what we're going to find in the next slide and discuss it in more detail is that as we move up that demand curve, that value of elasticity changes. And exactly how it changes, I'm going to discuss in this next slide. In the slide, we show a standard demand curve. The arrow indicates that as we move up this curve, the absolute value of the coefficient becomes larger. In other words, well, I'll give you that definition in a second. We have 3 distinct regions on the demand curve depending on the size of the price elasticity coefficient. If the value of the elasticity is less than 1, it's called inelastic demand. In other words, if you have a 10% increase in price and a 5% reduction in quantity, that gives us an elasticity of 0.5. That is considered to be inelastic. In other words, what it says is exactly that. It says that the percentage change in quantity is less than the percentage change in price. It's just not as elastic, or it is inelastic in effect. If the value of the elasticity is equal to 1, it's called unit elastic. This means the percentage change in quantity is equal to the percentage change in price. Not too exciting, but what that means is we might get a 10% increase in price, we lose 10% of our sales, so we have a unit elastic, or it's 1. Finally, if the value is greater than 1, it's called elastic. This means the percentage change in quantity is greater than the percentage change in price. So, for instance, if I raise my price by 10% and lose 20% of my sales, I now have an elasticity of 2. And of course, what it says is, that quantity is going to stretch more in this area. These boundary values have important consequences. Understanding the value elasticities and how it relates to total revenue is important. We define total revenue as price per unit times quantity of units sold. It is just total sales. It says nothing about costs or profits. Most companies believe if they raise prices, total revenue will increase. This is not always true and depends on the price elasticity of demand. Assume we have an inelastic demand. This means a percentage change in price will bring about a smaller percentage change in quantity. Let us assume the elasticity coefficient is 0.5. This means a 10% increase in price will bring about a 5% reduction in units sold. Thus, the revenue gained by the increased price is more than the revenue lost by the decline in sales. And in that case, an increase in price is going to cause us revenue to increase. Also, a reduction in price is going to cause revenue to go down. In the second case, that of unitary elasticity, the percentage change in price equals a percentage change in units sold, and this means a 10% increase in price will cause a loss of 10% of sales. This means the revenue gained by the increase in price will just offset the revenue lost by the reduction in units sold, and total revenue will not change. The third case is the most interesting, elastic demand. In this case, the coefficient is greater than 1. This means a 10% increase in price will bring about a greater than 10% loss of sales. So assume elasticity is 2. This means a 10% increase in prices will reduce quantity by 20%. The gain in revenue caused by the increased price is less than the revenue lost by the reduction in quantity, and revenue falls. So in this case, raising prices with elastic demand means revenue goes down. In this case, if you want to raise revenue, what do you do then? I'll let you come up with that answer, but it's pretty obvious. In the previous slide, I indicated as the price rose, the elasticity coefficient changed, and the price elasticity rose. This meant on a straight line demand curve at low prices, as we increased price, revenue rose, but the coefficient changed. The value of the coefficient rose. Thus, it eventually became unitary elastic and then elastic. Remember our total revenue test? Well, as prices rise with inelastic demand, revenue increases. When it reaches a value of 1, revenue quits rising. When we move farther up the curve, the demand becomes elastic and price increases reduce revenue. This means that revenue is maximized at unitary elasticity. I'm going to give you here a shape of some other demand curves. We're using straight line, downward sloping demand curves, but I want to show you some others that, or at least something we discuss a little bit in economics and becomes more important. So what we have to say in the previous slide only applies to straight line demand curves that are downward sloping to the right. There are other extreme cases where elasticity is not changed, and these are shown below. In this particular case, we have a horizontal demand curve, and I'm sorry if it doesn't look exactly horizontal. This is considered to be perfectly elastic, and in other words, no matter what, as the price never changes, and you can buy as much as you want at that price. So quantity can go up and down, price never changes. In other words, demand, perfect elastic demand, because quantity is not affected by price. We'll actually use this later in one of the chapters on perfect competition. We actually make use of it to explain how perfect competition works. The other one is a perfectly inelastic demand curve. And what this says is no matter what the price, consumers will purchase it. So, percentage change in quantity, 0. Percentage change in price could be infinite. So, you can see from that basically it's elasticity is 0. And the other one is actually infinite. And then we have a curvilinear. This is a curvilinear demand curve where the elasticity may stay constant continuously. It doesn't go up and down like it does with the straight line, but because it's curvilinear, it can have a constant elasticity clear through the demand curve. What are the determinants of the price elasticity of demand? Well, number one is number of substitutes. The more substitutes something has, the more elastic. And a lot of this depends on how we define the product. Let me give you a simple example. If I asked you, do you think the demand for gasoline is elastic or inelastic? Most of you would probably say, well, it's probably inelastic because, increase in price isn't really going to affect my purchases that much. But on the other hand, if I asked you, what do you think about the elasticity of demand for Shell gasoline? You might say, well, wait a minute, that's a particular brand and I can always go to another station. So if they raise my price a little bit, I'm not going to buy it there. You're absolutely right. So in this case, it depends on how are we going to define that particular product. If it's very specific or very general. You can play the same sort of thought game with, say, food. Is the demand for food elastic or inelastic? Probably inelastic. Well, what about the demand for steak? Probably relatively elastic. The other one is proportion of income. The larger the proportion of income it takes, the more elastic demand is. So expensive purchases are much more elastic, and that'd be things like automobiles, large appliances for your homes, even homes. Although I would point out with homes, I highly doubt that we really are as concerned about the price as we are the payment. But in those other cases, it tends to be more elastic if it takes a lot of your income. On the other hand, let's take the other extreme case. You go to the store, you notice the price of salt has gone from 25 cents a box to 50 cents a box, and you say, oh my God, that's a 100% increase. Do you not buy the salt? You grumble a little bit and you say, oh, well, it's not that big a deal. I can afford the other quarter. So since it's taking a very, very small portion of your income, that means it is probably going to be pretty much inelastic. Whether we consider luxury or necessity is important too. Luxury goods tend to be more elastic. Now, luxury or necessity is based on a couple of things. One's culture. Is something a necessity or a luxury? Well, at one period in time or in one culture, something that is considered a necessity might be considered a luxury in another one. Also, a lot of times items that are considered to be necessities are simply low-priced items in the first place. Luxury goods tend to be high-priced items. So a lot of things go into that thought, but in general, items that are considered to be luxury goods tend to have more elastic demand. And I would guess things like expensive jewelry would be considered luxuries and therefore have elastic demand. Time's important to elasticity too, for a couple of reasons. If you like to buy a product, you may not have a lot of time to look. And so, you're probably going to, if you need it really quick, you're probably not going to be as concerned about price as you might ordinarily. But if you have enough time, you're probably going to go looking to see if you can get it cheaper. And so you can save some money here or save some money there. It's going to become much more elastic. Good example I always have are when you're on vacation. You're in this area you don't really know, and you want to buy a product. It might be something as simple as toothpaste. So you go in the store and you buy the toothpaste, and you don't sit there and say, well, maybe I ought to check 2 or 3 more stores. I don't really know what the price of toothpaste around this place is. But you say, on the other hand, I got an opportunity cost because, I want to go, do some sightseeing. I want to do some fun things. I don't want to spend half my day looking for a tube of toothpaste. So what happens is you buy it. Why? You don't have the time. Now, when you're at home, you may have that time, or you've collected information over the years, again, part of your time, to know what a tube of toothpaste should cost in your particular area. What about application of price elasticity? Well, it's kind of important because it's very useful in many ways. One deals with large crop yields. It's a very strange phenomenon in farming. And that is, first of all, probably most commodities, corn, beans, wheat, have relatively inelastic demands. So, it's going to be a very steep demand curve. So small changes in prices don't make much difference to selling more. So if in a given year the farmer has a really bad crop and prices go way up, because it's elastic, prices have risen, he's probably going to generate more revenue. Conversely, if he has a really good year and prices go way down, he's probably, actually going to generate less revenue. So in some ways, a bumper crop, if it's really a bumper crop, is probably going to hurt them. In the last several years, we've seen really good crops, and the price of soybeans and corn have dropped pretty dramatically. I think 2 or 3 years ago, the price of corn was about $6. Now it's a little over $3. So that's a big change. Excise taxes. Well, excise taxes are simply taxes are a per unit tax on a good. And excise taxes are imposed on a lot of things. And, for instance, cigarettes. So we put an excise tax on cigarettes. Notice one thing. In general, we tend to put excise taxes on products that have inelastic demand. Why is that? Well, if a product has an elastic demand and you put an excise tax on it, you're going to get less tax money. For instance, let me give you a very real world example. I lived in Kansas City many years ago. The city of Kansas City had a city cigarette tax. And that was a way for them to generate money. Well, I think over the years they'd raised a little and raised a little and raised a little. Well, the last time that they raised it when I was living there, they raised the excise tax on cigarettes expecting to get more tax money. Guess what happened? Taxes went down. Now, why was that? Well, right across the bridge from downtown Kansas City, where thousands of people work, is another very small town called North Kansas City. It is not part of Kansas City. They have no cigarette tax. And so for a 5-minute drive, you can go over the bridge, you can buy your cigarettes and come back over a lunch hour, right after work, or right before work. And what was happening is the convenience store over there was bringing in a trailer truckload of cigarettes every week to sell to Kansas Cityans who would drive across the bridge to get it. So you figured, well, maybe everybody got together at lunchtime and said, let's pool our money. One of us will run over and get the cigarettes. Okay, so what happens? You raise the excise tax. People don't pay it. They simply go out. I was working in a low-income housing project, and when the checks came in, everybody pooled their money, found the person with the biggest car, and sent them outside the city to go buy cigarettes. And also at that time, gasoline was really cheap. Third is decriminalization of drugs. This is one that I thought was extremely interesting because I had really not thought about it. And in fact, I think I had, what their findings are exactly what I would not have expected. What the argument goes is that apparently studies are showing that the demand for drugs like cocaine and heroin are actually elastic, which means if you lower the price, strangely enough, the drug dealers are going to get more money. But the big thing is you're going to sell a lot more units because of that. That means you're going to have more addicts. So people are questioning, is this really a good idea? In the past I've always supported this, but this is a piece of information that I really can't ignore very well. Another measure of elasticity is called the price elasticity of supply. What this tells us is how responsive supply is, or quantity supply it is, to changes in price. In other words, it's telling us how much suppliers will increase or reduce production of their products or services when prices change. The elasticity of supply, we'll call that ES, is equal to the percent change in quantity supplied divided by the percent change in price. And again, we would use a midpoints formula to calculate this for the same reason we did the price elasticity of demand. Now, the thing that really determines the elasticity of supply is the amount of time it takes is allowed for change. And we identified 3 periods of time. One's the immediate short run. In the immediate short run, supply cannot change very much. So in this case, percent change in quantity supplied is going to be very, very small for any percentage change in price. Again, note though that quantity supplied and price move in the same direction. So this elasticity of supply figure is always positive. So immediate short run shows us that not much change in quantity is going to occur no matter what happens to the change in price. For example, if the price of corn rises in January, we're not going to be able to produce much more corn in January in Iowa. So that is what we would call the immediate short run. In the short run, that's a little bit longer period, we can vary some resources. We can probably, vary things like labor some, we can vary raw materials, but we really can't do things such as change the size of our plant or our facility. In our case, if it's a farm, we can change the amount of labor, we can change the amount of pesticides and herbicides, but we can't get any more land, so we can't really change the size of the farm. So in the short run, you can vary some of these things, but not all. What this allows for is a larger change in quantity supplied for a given change in price. So again, go back to my example. In January, we can't produce any more corn. The short run would probably be a few months, say between now and September or October. In that period of time, you could change the quantity supplied more than you could in the immediate short run. In the long run, you can change everything. You can buy more capital equipment, you can hire more labor, you can buy newer technologies, you can do an awful lot of things in that long run. And in that case, then, that percentage change in quantity supplied is going to be much greater with a given change in price. So what happens here is that the price elasticity of supply increases with time. In other words, the amount of time to increase production. And what it's also going to do is it's going to probably give us a supply curve that's going to be less steep. For instance, in the immediate short run, the supply curve is going to be just about vertical. In the short run, it's going to have more slope up to the right. In the long run, it can be a lot flatter. In fact, it may in the long run actually be horizontal because we'll be able to increase production enough for a change in price. Let's talk about some applications of this, and I give you 4. One's antiques, the other one's gold, and these are kind of closely related. Antiques we don't make anymore. I mean, unless you get illegal antiques, but let's say that you had something from the French dynasty, one of the French dynasties. Well, we don't make those anymore. So effectively, our supply curve for that is vertical. Any change in demand is going to drive price up quite a bit. But the bottom line is it's pretty much price inelastic. Price isn't going to create any more of this product. Kind of the same way with gold. Gold, for the most part, even though we can mine it and produce more, it's pretty much a vertical supply curve. We produce about enough to make up for that we used up in any given period of time, and it's been claimed that the amount of gold in the world really hasn't changed that much over the last several hundred years. So in that case too, the supply curve is going to be very steep, and you're going to have it's going to be very price inelastic. The other 2, reproductions and Beanie Babies, I've added, are going to be ones that are going to be much more responsive to price. For instance, we can have an antique and we can have a reproduction of an antique. If price goes up a little, we're just going to produce make more of the reproductions, and so therefore it's probably going to be fairly price elastic. In other words, you're going to get a fairly large increase in the quantity supplied of reproductions with even a fairly small change in price. I use Beanie Babies here because they're a classic case of not understanding economics. Many years ago, some of the fast food places started giving people Beanie Babies with their meals. It got so bad with McDonald's that people would actually buy them the meal, get the Beanie Baby, throw the meal away, and keep the Beanie Baby. And people started collecting and trading these, and people thought they were going to make a lot of money. Well, here was the problem. The elasticity of supply turned out to be very high. The problem is they were just too easy to produce and reproduce. So, the craze in Beanie Babies didn't last long. I can remember actually there was a section in a newspaper, in a classified section, just for Beanie Babies. Well, that's disappeared, and we really don't hear much more about them. And people who got a lot of Beanie Babies thinking they were going to make a lot of money very quickly found out that prices just weren't going to go up because production was going to go up quite a bit with any small change in price. So here was a case where you had a very high price elasticity of supply. There's another elasticity called the cross elasticity, and this is the percent change in the quantity of X divided by the percent change in the price of Y. Again, we'd probably use a midpoints formula. And here what is important is the sign we get on that cross elasticity. On price elasticity of demand, it's always negative. Price elasticity of supply, it's always positive. With cross elasticity, it can be either positive or negative, or it can just be zero. And that's going to depend on the relationship between the two products. Notice we're talking about a change in the quantity of X supplied divided by the percent change in the price of Y. So this kind of is interesting. So for instance, if the price of Y goes up, and then then we start selling more X, then what we've got is a substitute. So the price of Y means people switch to X and we buy more X. That's a substitute. That means an increase in price of Y causes an increase in the quantity of X. So that value is going to be positive. So if we have a positive cross elasticity, that means we have a substitute, two substitutes. What about complements? Well, they're the opposite. If Y goes up in price, and remember what a complement is, those are things used together. For instance, the price of razors goes up, we buy fewer razor blades. So if the price of Y goes up, then quantity of X goes down. That means this value is negative. So a negative cross elasticity implies that we have complements. And I'm fairly certain that companies like Gillette had a pretty good comprehension of how big what their cross elasticity of demand was for that particular product, meaning razor blades. And then finally you have independent goods, which simply says if price of Y goes up, nothing happens to the quantity of X because they're totally unrelated. Probably the reality is you're probably never going to find two goods that have a zero relationship, but you're going to find some that are very, very, very close to zero. For one thing, we talked a little about an income effect, and that could set in even though there's no substitution or complementarity. And finally, we look at income elasticity. Income elasticity is a percent change in the quantity demanded of X divided by the percent change in income. Here we're trying to determine how much income affects how much we buy of product X. Here again, the sign's important because most goods you're going to find the sign is positive. As my income goes up, I buy more. On the other hand, there are some that are going to be negative, and we're going to talk about those in just a minute. Normal goods will have a positive sign. Again, those are the goods that we buy more of as income rises. On the other hand, inferior goods, which were goods that we buy less of as our income goes up, are going to have a negative value. So again, here we see a situation where the sign is important. Also, the value is important too. Are we going to increase our purchase of X a lot with a given percentage change in income, or very little? And we have measured some of those. Some of those are actually in the questions we've discussed in class, and they're at the end of the chapter. But we find, I'm fairly certain that probably housing has a fairly high value, and probably automobiles do too. But those have been measured, and we would probably find that. On the other hand, do we eat more food, and do we spend more on food as income goes up? Maybe some, but probably not a lot. So that's the concept of income elasticity of demand. So in this chapter, we've really discussed different types of elasticities. Economists love them. Students tend to be a little bewildered by them. But they're very, very useful measures. For instance, one of the things I pointed out earlier that when we talked about inferior goods was the problem with mass transit is an inferior good. So what it tells us is the income elasticity of demand is negative. As income rises, you buy less. Not a good situation for a company. On the other hand, if incomes are rising and people are going to buy a lot more, then that's a very good situation for a company. So again, we've covered price elasticity of demand, price elasticity of supply, cross elasticity, and income elasticity.